So, welcome everyone. Who did not attend my first session this morning? Is there anyone who did not attend? So, you did not attend. Okay. So, but all the others have been in my first session. That's good. Okay. Well, this time I want to talk about profiles and extensions, and I want to show how to make profiles and to make extensions. It will be a little bit more practical than in the first part of this morning. Here in the slides that you will get in the afterwards, you know, maybe you can open the door for him. Yeah. Yeah, but there is someone wants in. Okay. So the first slides are the same, and I think I will not repeat them now. So we start in the middle with creating profiles. Okay, this does not work. Okay, and again. Okay, let's start with the question, what is a profile? So I think you have learned in the sessions that Datex in the level A model already is quite complex and extensive, and even the parking model is even more complex and extensive. And even the normal scheme from the Datex level A has got more than 15,000 rows, which is yeah, quite a lot. And the systems, the clients which are implemented, they usually only use a certain type of messages, and usually you don't use all attributes. A lot of them are optional, and you only want a small set of them. And also the enumerations, you have seen that we have got a lot of enumerations with a lot of values. They are not all used every time, and you like to limit them. So the solution is tailored XML schema, which is useful for a particular case. Of course, the problem is that clients and software costs also are corresponding from the number of classes to implement. So this is, of course, your aim to minimize the software costs in this case. There is a direct relationship. Okay, so what do we do? We're creating a Datex profile and selecting a subset of level A, for example. You can also include level B extensions and create a subset. This is the same mechanism, it does not change. But we will start with doing it from a level A model. And the most interesting thing is that we always have got a backward compatibility. So the aim is, if there is some client who can understand the whole Datex level A, which is very complex. I don't know if there is such a client in the world, maybe. But if there is someone who can understand everything, you also can understand the tailored profile, so you can also understand the small subsets. And this does also work with level B, because level B is backward compatible. So if we have a profile which includes the level B extension, a client of level A can also understand this, because he skips the level B extension. When he don't know the extension, he cannot know it. That's quite clear, because it's a custom extension. But he will not fail. That is an important point. He will say, okay, there is an extension. I know that it's a custom extension. I don't know the content of this extension, but I do not fail. I'm content with this. Examples for Datex 2 profiles is the profile for truck parking, which is quite new now in standardization. We have got a profile for traffic messages, for example, for the German mobility data marketplaces. There is a profile for strategic routing, which is a level B extension. These are popular profiles and profiles which are loaded on the website, because the website has a special place where such profiles can be published. But of course there are a lot of smaller profiles for everyday use, and of course you don't need to publish it. You can make a profile for yourself and use it, and that's fine too. So a profile is a tailored XML schema file, and usually you say that documentation should belong to this profile too, because otherwise it doesn't make sense when you cannot, when you do not know what this profile entails. To do profiling, we need the D2 conversion tool, which is a tool developed and maintained by the Datex community. And of course, you can use, this is the official Datex tool, but in particular, you can use own tools on yourself, or you can create open source tools if you like. So we tried to make it open source, but this is not the current stage. So it's an official tool which is working on an XMI representation of Enterprise Architect. And there are a lot of rules of compliance to fulfill, and this tool checks all these rules. These rules come from the methodology document. I will show them in the next slides. And yeah, with this tool, you can select the parts you like to have, and then the output is the customized schema file, the XSD file. So this is the tool. Of course, I will use it in reality in a few minutes, but first in this show, I will show it here on the slides. So I will explain the fields later on of this tool. This is again methodology. You don't need to read all the stuff because I made some summarization. These are rules of Datex which have to be fulfilled, because you cannot make some UML model and say this is Datex compliant. You have to fulfill several rules, and the tool checks if these rules are fulfilled. This is especially necessary for extensions. If you use the Datex level A model, of course the tool shouldn't complain, otherwise something went wrong, because the level A model should be correct by definition. But things which have to be correct are, for instance, these. Classes are allowed to have attributes, and attributes need to have a text value definition. I already explained this in the morning, as well as other Datex elements too. Attributes need a text value order. I already said that, because in the XML schema file, the ordering must be consequent right to this order attribute, and they need a multiplicity. If you reuse an attribute more than once in the Datex level A model, you have to use the same name, the same definition, and the same type. So for instance, a good example is the attribute height. Okay, one further down. In the parking model, I wanted to use the attribute height to specify the height of a parking space. And I realized that the attribute height was used in the level A model in the TPEG lock context. And the attribute name was height, but the definition did absolutely not match on the height I need. And so I wasn't allowed to reuse the same attribute with name height, because otherwise I had to use the same definition. Yeah. And yeah, the Datex does not allow this, and so I had to create another name for it. Again, this is a view on the tool. You will see in practice in a few minutes. This is a tree structure of the data model. And you already can see that there is a possibility to select or deselect elements. And with the tool, you can make three elementary things. You can select different components. You can modify multiplicities. And you can select enumeration literals. These three things work like the following: the selection of components. Okay, yeah, when you deselect components, of course, this is a very strong reduction. Yeah, you say I only need the measurement table publication. All other things I don't need. Of course, your schema gets very limited then, and all the other stuff is not entailed anymore. Wonderful. Of course, there are some mandatory elements. They are in gray color here. You cannot deselect them. And in this stage of the tool, you cannot deselect things if they appear several times. So maybe if you have several location references and in one location reference you like to use linear, and another you like to use points. This is not possible to distinguish, so you have to allow linear and points, and on both occurrences you can use from the schema linear and points. But this will be, I think, another feature of upcoming tools, that you can, on different occurrences, can select very precisely what you need. If you have this problem, you must write into your documentation that on this special stage only points are allowed, and on another stage only linears are allowed, for example. Since the Datex version 2.1, you can modify the multiplicities. That means you have some small window where you can do this, and you have the original lower bound and the original upper bound, and you can modify them. But of course there are rules to do this because we want to have backward compatibility, and it's only possible to increase the lower boundary or to decrease the upper boundary. And you cannot go about each other's limit. So that means if you have an element which is either 1 times or 2 times allowed, you cannot say in your subset it's allowed 3 times. You can say it's allowed 1 times or it's allowed 2 times, but of course you cannot make a totally complete different set of it. So what you can do is you can make a mandatory attribute, an optional attribute mandatory. This is allowed. You can limit an unlimited attribute. Yeah, it's from 0 to n before, and you can say I only like to have it at a maximum 3 times. Or you can make some limits stronger. When you have got a limitation from 1 to 4, you can say my new limitation should be 2 to 3, for example. When you have a mandatory attribute, which with multiplicity 1, you cannot do anything. It's mandatory, and you cannot change this to other values. Working with Enterprise Architect, this is quite difficult because when you try to change the multiplicities in your view, you change it in the level A model. So this is a thing you don't want, and you change. You are not allowed to change the level A model. So it's not very easy to visualize this in your screens. And in Enterprise Architect, you can do it with some text elements. So you can hide the actual multiplicity and to fill in another text element with a new. This is some sort of tricky, but there is no other solution so far. The third method is to limit the enumeration literals. We have got very long lists of enumeration literals which are not needed from every partner. There are a lot of requirements for all these literals, but in fact often they only use 1 or 2 of them maybe. And so there is a wish to limit them in your particular profile. It's useful to keep a literal which is called other because there are always situations where the literals you selected are not enough, and then you have the possibility to go on to another. This is easier to show in Enterprise Architect because in Enterprise Architect you can, for every view, go onto the tab for feature visibility and to deselect things. So it's possible to have in this special view a selection which is smaller than the database in the background. Here you can see it. We have an enumeration for accident types. And what we want to have is an enumeration which has the elements accident, serious accident, and other. Maybe that's enough, more we don't want. You can see we can make it in Enterprise Architect. This is a restricted view. And in the background, the list is as long as here, but you have a view on it which is smaller. And the corresponding view in the tool would be like this. You have got here the long lists of literals, and you see here, here, and there we marked the 3 literals we want to use. In the tool, you can save your profile in the Datex tool. So if you make your selection, the selection can be very complex, yeah, because you might have to stick very deep in the tree to select special things or to deselect special things. And you do not want to do it again all the time. So it's possible to save it and to reload this selection later on. I will show this in reality. And yeah, what the tool does, it checks against the rules and it produces a schema file. Okay, this is the summary of the profiling. Yeah, as I said, we have a freely available Datex tool to do this, and we have a slim XML schema as a result. And so you can focus exactly on the things you like to transfer. The need is to reduce, of course, software developing costs. And level B extension is another chapter which will follow afterwards. So, okay, now we will make a profile, and I will show how to do this. For this profile, I use the original Enterprise Architect file from the Datex website, which is actually the number 2.2. And there we can have a look at the parking. The parking extension is inside this version. It's not the very newest version, because the very newest version is the extension which is on the website. But there is an older version inside the Datex version 2.2. And this is included here. So it's not exactly the version I showed yesterday, but this doesn't matter for our problem here and for the show here. So what we have here is a parking table publication, which is, the new one is very much bigger, but this is also big with a lot of things you can add here. And okay, usually people say this is too much and I want to have a very limited set of information I want to transfer, and I want to have a profile which is very, very small. Okay. And now what we do is, the first thing I did, there's one small difference I did. This is for the level B extension. There is a package polygon area inside this extension. I deleted this package because we want to make it, we make it in this session. Yeah? So I deleted it before. This is the only change I did to this official Datex UML version here. Okay, but now we are going to start to make a profile. And let's say what we want to have is some parking facility tables, so a collection of something, and we want to fill it with parking areas. And nothing else. So maybe we don't need parking facilities and all the other rest here. What you can see, there are a lot of things, tariffs, opening times. This is not interesting for us. What we do want to have is a table of parking areas with a location, of course, best with an area location, with a name and with a capacity. And that's all. Yeah? You can imagine that maybe in an urban scenario, they want to define parking areas and they want to say there are 500 spaces in total in this area and 415 of them are free or something like that. Okay, so that's what we want to do. And first of all, we need to make an export of the model. Therefore, we use here, we always use this top class, D2 logical model, and say export, import export, export to XMI. XMI is, from the structure, it's an XML file, but it's an XMI standard to express the model in a standardized form the tool can read. So that means you make here this. This is wrong. I got to go to import. We want to export it, of course. Okay. Then, of course, you need to select a destination. The XMI type is 1.1. You don't need to change this, and you can say export. in this special case, you could use the given XMI, which is developed with the Datex package, because we did not change anything, and so we can use the file, which is. I think that the XMI file is included in the Datex website, but it couldn't change to make a new export. So, and while it is still working, okay, now it's ready. And now we need the Datex tool. So, okay, I can explain this screen of the Datex tool now. Here you choose the XMI file. I can do the serial work then when I choose this file. 1127, yeah, perfect. He's reading it, and sometimes this will last a little time because the tool needs to process this model. Here on the second part, you can choose the output directory where to put the schema files at the end. Here you have got information about the model, and this information is catched from the tag values. So the tool will, of course, it will prove the first things, and it will check if there is a class D2 logical model. And as we saw in the first session, the D2 logical model class has tag values, and the tool will collect these values and will fill in the information here, especially if there is an extension found, if there are extension names and versions, if there are, the version of the Datex tool will be, will be filled in here. This is automatically recognized by the tool. Okay, so now he filled in all the information. Yeah, the XMI version, this is a standardized format of this version is 1.1, and the Datex version, which is more important, is 2.2. And we already have an extension because the parking extension is part of this delivered Datex model. So there is, yeah, he found an extension. When we emptied the extension folder, when we deleted all this parking stuff, he would not fill in anything here, so he would not found any extension. But now he finds the extension, but this doesn't matter. This is okay for us now. Now we go on the second tab, selection. And now we have here the model. We exported everything, so we have got everything here. You can, if you like to, this is another possibility to browse through the Datex model. As you might remember from the first session, we have all the things I mentioned here, the big publications, yeah, elaborated data, measured data, VMS, etc., etc. What you can do, we can do it in before. We can make a complete schema. This is no problem. We just need to press start, and then we will produce a complete schema for level A. This will be useful in the future. This is a very good message when there comes no warning. Often enough, when you change something, then you have got warnings because you forget something, or especially order attributes or definition attributes or things like that. The tool checks all these compliances, and this is a quite good message because we did not change anything. So it's. I hope that there will be no warning. Okay. Now he already produced a schema. We have to locate it. Okay, he named it Datex II schema 1130. This was produced right now. He always uses the same name for it, so it's very useful to rename it right after creation. So this is a complete schema of level A. Okay. So, and now we want to make a smaller profile. I think the best thing is to deselect everything and then to restart what we need to have. And what we wanted to have was inside the generic publication, because the parking extension is located inside the generic publication. We talked about the parking facility publication that we wanted to have, the parking facility table, and the parking area. Okay, and maybe we make here our selection. So he makes the selection everywhere where it's necessary. We see that there is some header information which is necessary and some others, but the parking facility table name, for instance, is not necessary. He left it out. And from the parking area, he selected everything. Maybe we don't need these two attributes. We can deselect them. Here is another link to a parking facility, which is a very complex. If we would leave this selection, there would be another complex model. So we deselect it. We don't want to have the parking facility. We are only interested in the parking area. And this is a georeference of the parking area. We have to have a look that everything here is selected, what we want to have. You see that we can define our area in an ALET-C type or in a TPAC area type. Let's say we want to have ALET-C. And let's have a look that everything is selected. Okay, that's fine. So we can make our ALET-C area there. And to prepare for the extension, we will make what we don't find here is an area by polygon, an area by coordinates. Because this is not part of the Datex standard, but this might be quite useful, and we can keep that in mind for our extension afterwards. Okay, but what we want to have is an area of ALET-C and with a capacity and a parking area name. So, you remember we had three methods to manipulate here this view. And the first one was to select the things we like to have. And the second one was to select multiplicities. And let's have a look at the parking area name. So the parking area name has got a lower bound of 0 and an upper bound of 1. That means it's optional. And maybe in our profile we want to make it mandatory, because we want to have every message which is delivered should have a parking area name. So we make an upper bound, a lower bound of 1. The upper bound remains unchanged. So this means we have a mandatory element now. And maybe we do the same here with total parking capacity. It's also optional, and we say now it's mandatory. And we have a small star here indicating that something has changed, that you can see this. What we don't have here is an example for an enumeration, but I will show it anyway. In a part of, we do not select, but we can show it. Maybe the parking facility type. The parking facility type is a data type. In this case, in the newer parking version, things are a little bit another way, but this does not matter. If we would use the parking facility type, we could say, okay, we just want to limit it to something. Yeah, let's say only airport parking and nothing else, or as we like to. Yeah. But this is only an example. We do not want to use it here. Okay, he changed it now, but we did not select it, so this is okay. Okay, now we have our selection. And what we can now do is to save this selection, which is very useful, because then we don't need to reproduce this once more later. Okay. And now we can start creating our schema. And again, he checks everything, if connections are okay, and of course, there should not be any warning now. And he says it's okay, and he created our schema. So, as I said before, it has the same name than before. It's called Datex II Schema 2.2, 1136. So, We can rename it to parking area. Let's make a 1 afterwards. And the first thing you see is the complete Datex schema we created before has a size of 279 kilobytes. And the schema we created now has a size of 19 kilobytes. So of course it's very much smaller. We can, of course, we can open it. If you're used to the look of a schema in the editor. And we can also compare it. So here you can have some schemaized view, but this is a text view. I don't know, this is not too informative right now, but you can see what is inside. You will only find the things we selected, yeah. So you find some things like the LHC area, like the location codes. You find some elements which are part of the exchange because they are mandatory. We cannot deselect them. This is a long list of the countries because you need to specify from which country the message is publicated. But in general, most of the things are things we selected, and only a few mandatory elements are inside the schema. And we can try to have a comparison between these files in a WinMerge editor. And now I open the complete schema created before on the one side, and on the other side I will open the schema created now. Parking area 1, this one. So, and I don't know if you are used to this tool. You have got two sides, and you can see the differences. Especially here, you have a complete view on the file, and yeah, what you can see is there are a lot of differences because everything is in a yellow color. That means the yellow color is are elements which are in the complete model, and here on the right side they are missing. You have got elements on the right side too. That is, I think that is a problem of this WinMerge because all elements on the right side must be entailed on the left side too. I think he has got problems to match these very large files correctly, and we do not have any new elements which are not on the left side. But you can see, of course, we shrink this very, very much. What we can do now is we can produce an XML. That is maybe more interesting. Producing XML, you can have editors for this, you can have software for this. When you have a schema, it's no problem to create an example XML. You can do it by hand, or you can do it automatically, or can do it in a kind of mixture form. I already prepared it, but usually it's not too difficult. It depends, of course, on your size of your schema. So we have a parking area example, and you see such an example file is really very small. Yeah? It's of 48 lines. And one of the important things is, of course, that a reference to the XSD. I made an XSD before, but I can also reference to the I can make a reference to an XSD which is not existing. Number 2 does not exist. Yeah? He will complain because it does not exist. So number 1 we made for a few seconds ago. Okay, and he will not complain. This is the validation. Yeah? He uses this schema and validates my XML to this schema. And if I change something, for example, I say here national identifier instead of national, then he will complain, of course, because in the schema a national identifier is foreseen on this place here. So you can see it's XML, which is exactly for this special schema. And you can see what we have. We have a quite small package of an XML identification where we have a country and some national identifier. The main part of it is a generic publication of of type parking publication. This is the name of the parking publication, yeah. And we have a header information, and here is the information we are interested in. We have a parking area, and this was one thing I explained in our first session. We have an ID and inversion, because usually it's interesting to identify these objects in the static part, to re-reference them in the dynamic part, and therefore we use a unique identifier and a version. And here are the two attributes we wanted to have. We wanted to have the parking area name and the parking area capacity. And you might remember that we made them mandatory. So if I move out the capacity of my message, he will complain. Yeah? He will say, okay, the capacity is mandatory, and where is it? So this works, and every message we send needs to have a capacity and a name. For the name, also I said in the first part of my lecture, this name is a multilingual string name. That means we have here the English version, but it's possible to insert another version. For example, a German version, which language German, and where we can say, some German name, yeah. And the idea is that multilingual strings are presented to the end user in some system, in some client system, or on some sign or something. This would, of course, validate too, because it's allowed to fulfill here a lot of names in different languages. Okay, and the next thing what we have is the georeference. We have got the area georeference of kind LHC area. That means in this case we use a German LHC table, and we give some position where we have it. And the special problem in this case is, of course, that parking areas are not coded in any LHC list, and maybe we like to have an area defined by polygons, and that's what we're doing next. Okay. So now we are going to use extensions, because we want to have some more information which we don't have, which is not provided in the Datex level A model. I already introduced the interoperability levels. Tomorrow morning I introduced the level A, the existing data model. And now we are talking about level B. Now we have the special situation that the parking publication is a level B extension itself. This does not play too much role here. Because we like to extend the area. Area is a Datex level A model, and that parking is itself level B. That must not borrow you here in this case. So now we are talking about level B. I said before, it's backward compatible. The real nice thing in this mechanism is the fact that that every client can understand level B extensions in the case he will ignore it if he does not know it. Maybe I should show another thing in the example. I stripped this XML into the slimmest possible form, but there is, for every class and every component, there is another tag, an information extension tag. And an extension tag, let's say it like this. So I can insert it here, and I can insert it everywhere. So the parking area or the LHC area, they all have extension tags. And it will work. And inside the extension tag, I could write anything. No, not anything. Okay, but in this tag, everything is allowed. So this is kind of the extension mechanism that the compiler can expect some additional information there without knowing what it means. It's actually of type any. We can see it in the XSD. There is a general extension type. Every component has an extension which is pointing to a general extension type here, and which is of type any. And that means that is a preparation that the system is able to expect data anywhere without needing to know its content. And this, it's a quite special mechanism, which is very useful for our extensions. So, okay. Level C, I explained this morning. I will not show level C, but level C is the possibility to make an extension with a different namespace, with completely different attributes when not caring about the traffic message from Datex. You can use Datex methodology principles without using Datex itself, without using the Datex data model itself. Okay. Now let's show some principle of an extension. When we have got some vehicle defined of brand Ford, you can see here the extension tag, it's already included here. Then, okay, your client computer understands the brand of the vehicle is Ford. When you make an extension, and when you say the brand, it's not its visualized. Yeah. I don't know why you cannot read this. I think it comes later. Okay. When this computer sends a message to this computer, he can also recognize that the brand is Ford. Yeah, this is too dark. I don't know why it is too dark. So this says here the brand is Renault. And the color of the, it's an extension, yeah, and it says the color is green. And that means he interprets the Renault as a green, and he interprets the Ford without color, because here no color attribute is sent to this client. He can understand it, but there is no color and it doesn't matter, okay. Yeah. Only when the extension which is known to this computer comes, he can interpret it as the right color. On the other way around, when a computer sends an extension, he sends the information green. But this computer is silly. He doesn't only understand the main model, and he only understands, okay, it's a Ford or it's a Renault, but he does not have any information about any color. And now we have got a second extension actually, which is a BMW, and we have another extension of the type, and which is a cabriolet. And when we now have all these connections, we can say the following. This computer knows only a brand and a type. And when he gets the information from his BMW, it's perfect. Yeah, he has a BMW, which is a cabriolet. When he gets information from the standard, okay, he has only got standard information about the Ford without any type. And when he gets information from this extension 1, it's also only the information about the Renault without a type, and the information of color is skipped. And all the others are right in a similar way. Here again, the middleman doesn't know any type, he doesn't know any color, he has only the information of the brand of the car. And especially, this client is not unhappy with this. He does not say, oh, there's a color, I don't know color, and I like to crash. He says, oh, there's anything, but I don't know anything, so skip it, doesn't interest me. I only have the information about brands. That is the principle of the backwards compatibility. Again, we have some rules for the extensions, and it's a lot of text, but it's quite simple to translate into our language. Level B is backward compatible and level C not. You can say that. And also the extensions, of course, must follow the basic rules for the level A model. And the tag values extension name and extension value version are to be used to identify it, yeah, to have information about this extension inside the tag values. Of course, these are not always all rules. There are more rules, but these are the most interesting rules I present here. Okay, then of course you have to define some entry point, and that means when you extend something, you have to give an extension give a tagged value extension level B to this class. So the computer must know where level B extension starts. Otherwise, the tool is very silly. When you don't do this, the tool thinks it's a level A model. The Datex tool does not know our level A model, of course, yeah. And when you give input, the tool thinks everything is level A. So you have to say where level B really starts. Okay, extension classes must not be a superclass for a level A component. Yeah, that's quite clear. You are not allowed to make some kind of circles that you start to make an extension and then go on a specialization into level A. That's something which is not allowed. Quite clear. And but you are allowed to reuse level A classes. So when you make an extension, you can say my extension class should have elements from level A. We did that in the parking model, because in the parking model, which is an extension, it uses the area. For example, area is a level A class, and this is exactly the case. In a level B extension, we use level A elements. And you are also allowed to use enumerations from the level A model. This is a level B extension. We will make a level B extension in a few minutes. This is another one. This is not the correct picture of the thing I will present today. But this is nevertheless a very nice level B extension where we have a level A model of traffic speed with a speed value. And we have an aggregation besides is the average speed value. And what we did not have before was a min speed value and a maximum speed value. And that's why we introduced a level B extension, traffic speed extended, and we introduced these two aggregations to the existing level A class. The coloring is not it's not predefined in Datex. Also usually you can print it in the same color like here. But especially this connection is a level B connection. And it's not the same like an arrow in a black color, because you use the tagged value extension here. And thus makes this a little bit different. And what I do is I like to color this arrow in some red color to see the difference. The Datex community is going to decide to change the symbol, to use another symbol, because it doesn't make sense to use the same symbol for two different things. You have got a lot of text value in level A as well as in level B. And here I made some overview where you have different tagged values which are mandatory. So we have the definition, which is a free text where you define the elements. Definition is used everywhere. Yeah, you can say that packages, components, attributes, literals. Even if you do two parallel aggregations, like in the slide before, we have two parallel aggregations from the same component to the same component. To distinct them better, it's mandatory to give a definition for both of these aggregations. The order attribute is needed for attributes, for literals, and for aggregations. This is something it's often forgotten to give an order to an give an order attribute to the aggregations. The extension level B is only used for the root components of the level B extension. I explained that before. We have extension name and extension version in the main component. And for references, we have the tagged value target class. When you make a reference, you need to give the type of target class where this reference will point to. And here on the right side, you can see how it is looking in Enterprise Architect. For instance, here you have got the extension level B tag, and here you have got the definition tag. The definition, as you can see, also packages need to have a definition. And the definition is a typical case where you like to do it a very fast way. The most convenient way is to make a package, call it package A, and to give a definition package A. And for classes the same. But of course it's not very useful. It's very likely that you spend some minutes to find a good definition which is very useful. But also for me, often you like to make it very fast and to say, okay, it's quite easy. I use the name for the definition as well. But the definition is a quite powerful tool, and you should really spend time for good definitions. Okay, this is the export of XML. We already saw this, and we will see it again in a few minutes. This is also no new information because we will come to there. Okay, I think these are all the things we will see in reality. Maybe we come to this slide at the end. This is not necessary right now. Okay. Okay, so now we go back into our model. Here in the parking model, we wanted to talk about the area, and we wanted to have a polygon area now. And the best thing we can do is we create a new package. That means we add a package, and maybe we name it polygon area. We should place it in the extension folder, because the extension folder is the place where level B extensions have to go. And we create a diagram polygon area right away, which is empty at the beginning, of course. And okay, now the first thing we should do is we need to make a tag value for the package. Yeah. So tag value with name definition. When we have to be careful about spelling errors. When you do not spell definition the right way, it will fail too, because you search for the tag definition. And I can say an extension for a polygon area. Again, this definition, I don't know exactly about the definition of packages, but at least all other definitions of classes, aggregations, etc., they will be inside the schema. And most of good software versions will show these definitions for the people who build the software, who build the clients, who build the class models. They will have software which automatically generates these definitions, and so you can have a look when you fill your schema or your XML file. You can see the definitions right away. Okay. So inside our view, we have nothing so far, so we need something. And best thing is to have the area. So we have a look where the area is located. At best, we should use the class area. No, not find in diagrams. We say located in the project browser. So you can see the area is located here in the group of locations package, in an area package, and here you have got the class. Here you have got the class area. Now we drop it into our view. We did not change anything in the model because this is a view, and what we did is just we made a view on the area. This is does not change anything. Yeah, it's just a nice view. We can have a look at the truth. What connections has got the area? And what we see is we have a connection to an LHC area. We have got a connection to an area destination, to a location, a connection to a parking area, and to a TPAC area connection. Now we could have a look what all these different things are. So, but we know this LHC and TPAC area are the types of areas we really have. And these other three things are connections where area is used. Especially we use it in the parking area, that's why we use the area itself. But we don't see any polygon area, for example. Okay, so the next thing is we go into the resource monitor and use our UML profile. Here in this moment it would be possible to use a class here from the standard enterprise architect features. You can do that, this is not prohibited, but it's not very useful, and especially in former UML versions this will give problems. The best thing is to use the predefined UML profile for Datex II and use the class. Unfortunately, this profile is not very perfect because it gives a stereotype class, and the best thing is to delete the stereotype. But you can see that there are, for instance, tagged values, and you have a tagged value definition. Of course, you can fill in this definition, probably at first. I copied some text here. This is not very interesting here to create definitions. Okay. The other elements are not, you don't need to fill them. You can say if there's something changed from former versions. You can say if there are some origins or origin codes. For example, if there is a TPEG correspondence or something, you can mention it here. This is additional information, but the only information really important is the definition tag. Of course, you have to give a name. And because we want to extend the area, we say area extended. Okay. And as you in the slides before, we need to make a generalization, which is only the symbol of a generalization. In reality, it is no generalization. And to specify this, we need to specify another tag value, which is not already there. We need to specify the extension level B. And now, the tool will know this is not part of level A, this is our level B extension. Okay. The second thing is we need another class because we want to have a polygon area. It's you could use this class, but it's more nice to create another one. And this is an aggregation. And we could make it optional. That means we select as multiplicity from 0 to 1. And now we have the polygon area. Of course, we need a definition for the polygon area. Okay, so the next thing would be to add points. Of course, we can add some class and add longitude and latitude and say this is points and so on, and we can add it. But you might remember it is mostly recommend to use level A elements, and of course, point coordinates are in level A. And so we use, first of all, we have a look, and therefore the tool from Jan Wyszynski is very useful because sometimes you don't know what is in level A. Yeah? You might not remember, or you might not know, and then you have to search. And maybe the tool from Jan Wyszynski is useful, and but you can also look here in the model or coordinates. Let me look for coordinates. And as you can see here, we have a point by coordinates and point coordinates. I can look in some diagrams. Okay, the diagrams here, group of locations, point. Let's look at this diagram. And what we see here is there is a point in level A, a point by coordinates, and point coordinates. Okay, and this is the one we want to need. So we locate it in the project browser. He says in the project browser, he is of course in the group of locations, and there's a class point coordinates. Now we go back into our figure and we use the point coordinates class as simple link, and we can place it here. Maybe we can make it like this. Okay, and maybe you remember we are allowed to reuse level R classes in level B. That means we are allowed to make here an aggregation. Of course, the other way around, it's not allowed. It's not allowed to make an aggregation like this, because that would mean the level A model point coordinates has got another aggregation which is not level B and which points to polygon area. This is not allowed. Yeah, so you can make level B extensions like this, but you cannot modify level A. This would be a modification of level A, which is definitely not allowed. So we need to remove it. Okay. What we can do now, the most, I think we do it like this, is to make a multiplicity. Okay, when we say a polygon area, we should have at least 3 points. And we might have an unlimited number of points. So let's say 3 to star of multiplicity. This might be useful for a polygon area. In fact, I think we will not change it here in our example, but in fact, this is an unordered set of points. And this is not useful for a polygon area when you have an unordered set, because for a polygon you need an ordered set. And an ordered set you would make with an index qualifier, so you can order them in the right direction. For our purpose here in this example, this is okay. Of course, in the XML you will have an ordering of your points, and you can, I think in 99% of all cases, the software will go right in the steps in the XML, the points are provided. But to make it very correct, you have to use some other kind of structure with an index attribute to reference them with a right ordering here. But for our example, we leave it like this. We have an unordered set of points. Okay. Now something we missed, because you might remember, we don't need a definition for these aggregations, because it's only one aggregation. This is fine. This can stay without definition, but this aggregation needs an order attribute. The tool would comply. Maybe what's the time? Yeah, I can show it. Why not? Let's say we are ready like this. And the next step is as before. So we say we export our model. Maybe we give another name now. And we export it. Yeah, he wants me to save the diagram. Okay. Now again we go back into our tool. The tool can it's no problem to select a new file and then you will reread this. You can also start the tool new, but it doesn't matter. When you select a new input file, he will cancel all old information inside. I think this one was the one I created. Okay, and now he starts loading. What we missed, but I think we will make a second try in a few seconds anyway. What we missed is to change these values. We could have put the extension name polygon area and some internal version for our polygon area. We did not do this, so these values will be the same now. But when we do it right away after once, we can change these values. Yeah, this is the only problem is that the tool needs to collect all the data and to import it. The tool is being developed right now, always. It's not a stopped invention. And it became faster, especially in the selecting of the tree. But therefore, it has to load, of course, the model in advance. And this is a step which takes some time. Okay, now we go to the selection. And as you might remember, we saved our selection, so we are able to load it now, area 1. And that means here only the things we previously selected are selected now, or the others are deselected. So now we have to have a look inside the tree, the parking area. Okay, and we have our LHC area again, and especially we have an area extended, which is not selected right now, of course, but which we do select right now, with our polygon and with our point coordinates. And they're not selected yet, but now I select them. Okay, and now we are fine, and now we are going to start the tool. And that's what I said before. He found, it's actually a warning. I don't know, maybe he even gives out some schema, but he found that the order numbers rule was not fulfilled. He will find it now. If he said one time, we can have a look in the log. Only the one with the warning are interesting. Okay, yeah, there are two of them here. Found that the order number and association between polygon area and point coordinates does not exist, or has an illegal value. So exactly what I mentioned before. That means we have to go here to this aggregation, to the connector target, and to add a new value order, and to order it with 0. This is even necessary if there is only one aggregation. The idea is, of course, if there are more aggregations from area extended, that they are in the right order. But if there is only one, we have to fulfill this rule anyway. And here the same. Okay, and then the thing I mentioned, I will have at the base, a look at the base class, and we say now this is our polygon area extension version 1. Okay. Then we export again. Okay. And then we switch to the tool, and we have to reload it. Now maybe, meanwhile, I can show this slide. On the website, you have special folders for profiles and for extensions. And you can see here some things which are published. The profile folder is quite new, so there are not so many elements. In the extension folder, there are more elements. There is a second slide not shown here. Especially, I think a lot of people make very small extensions which they use in their private scene, and they do not publish it. So you may see here very large and very good publications. I think the OpenLR, okay, you have got the OpenLR extension here. You can make a linear by coordinates here, which was missing in the level A model. Of course, you have the parking extension, the very big and new one. And you have got some other interesting things. You have got some profiles here, for example, for traffic times and traffic condition. Usually there might be small extensions, but usually there needn't to be extension. This is just a profile which is focusing on travel times. Yeah? Or for mobile lane closure trailers, a quite interesting one, or traffic light information. So this is information you can find on the website. And of course, you can directly use it. You need to import it into your extension folder, and then you have it available. Okay, now he's ready. And again, we have to load our selection. I didn't save the selection the second time, so I have to renew here the selection. Okay, this is what we want to have. Okay, then we can start. And now he will not give any warning. Wonderful. I did not show you here. Now he found a level B extension, and now he called it polygon area extension version 1, of course. Okay, so now he created our schema. No. So, best thing is to rename it right away. Like this. And now the comparison in WinMerge does make more sense. So on the left side, we use the parking area schema, created in former times, let me say that like this, and the polygon area created now. Okay, and we see it's much less difference, of course. Okay, one difference is that we have a new extension type. This is an internal type. You might remember that we have an extension type in the general schema, which is referenced by all components. And now in the special area component, we are referencing an area extension type. And that's why this area extension type is a new one here on the right side. The next difference is here. There is an area extension. Yeah, of course, we renamed it. Yeah, the former name was right. Element name area extension. And no, of course, no. This is the extension itself. So we are talking about the area, and we have an area element, area extension, even in the former type of model. And in the former type of model, we reference the general extension type, as every component does. And here is the difference now. Here we are going to the area extension type now instead of the general extension type. This is a place where the extension is placed into the model. And this is the case why programs do not complain. Yeah? They see, okay, there is an extension, okay. it points to another component, but this doesn't matter. It's okay for me. Then we have area extended. This is our new class we introduced. Of course, this is entailed here. Then, okay, this is extension name and extension version. This was the tagged values I changed. Yeah, you see it here, of course, the new name I gave. And I think we have another complex type, the point coordinates, yeah, because the point coordinates are in level A, but they have not been in our profile we made before. These are the differences. And what we can now do is we can make a new example. We can make a new XML. We should reference to our polygon area with polynomial. I thought I made another name. Now I have to look what name I gave. This one. This was the name I gave. So this XML is referencing to my new created schema, and it should work. That's the first. Okay, and now we can have a look what is different here in this message. The upper part is nearly the same. I did not change anything here. The language of the language name and the capacity. We still have included the LRC information, but here you can see the area extension. And the area extension says we have a polygon area with some point coordinates. And remember, we need 3 of them. When I leave out one, he will complain because 2 is not enough. On the other hand, I could add more. Yeah? We set unlimited, so it's no problem to add more coordinate points here. So that's very fine. And we can even try to make this on the old schema. And the old schema was, it was our parking area 1. Parking area 1. And the parking area 1 does not know anything about the polygon area and about point coordinates, but it works, yeah, because it says here's an extension. I don't care about this extension. Everything is fine. That's what we wanted to see. And now we can have a look at the slide you saw very shortly before. This is some table. You have XML instance. When you do not make any bug in your XML, and you have got 2 schemas. You have got, here it says traffic speed extended, but it's the meaning of an extended schema. It doesn't matter what name here is. When you have no bug in your schema, it will validate. And in the D2, in the complete schema, it will validate, of course, 2. When you make a bug in the level A model, that means when you write a wrong name somewhere, yeah, of course, both will not validate. The validation against extended schema and the validation against the original level A model schema will not validate because there is a bug. But when you make your bug in the level B, the extended schema will not validate, but the level A model will validate because for the level A model, it doesn't matter. We can show this. We have here our example. Just before, I put out 1 point so that we have only 2. I do this again. But you remember, I do not validate against the extended schema, but I do validate against the profile. And the profile says, it doesn't matter what's inside, it's okay for me. Yeah. Only the extended schema will not validate because he knows what has to be inside this extension. Yeah. Let me have a look if I have something more. but I think it is. Yeah, one more slide of an example of measured values. We had, yeah, this part is too complex, you don't need to interest for this part, but we had a problem that there was in level A only the possibility to put one measured value into a sequence of data, so you could not put historical data, for example, into the messages, and there was a problem when you had different intervals, when you had different intervals of incoming data and different intervals of outcoming data, there was a problem of losing data if you can only transfer one element. And that's why, and here you have a connection 1 to 1 at maximum. Yeah, you can leave it, I think you can leave it out. This is 0 to 1, but you cannot put in more than one value. That was a problem. And therefore, we created a level B extension. Yeah? That means we have another class here, an extension class, and this class can deliver more than one value. And yeah, this is an example for another level B extension. Yeah, that's it. I hope you enjoyed. I hope you understood. I hope you can use it, or yeah, I hope you had some fun. Thank you very much. Okay. Of course, questions, yeah, no problem. Yeah. Okay. Yeah.
Where can we find this tool? Can we download it somewhere?
Yeah, you can download. There is, I can show the link page. Yeah, I will show a page with links. Of course, you will get all the slides, but you can also write down the links. Okay, I hope it's not too small, but here you find all the interesting things. I think the browser from Jan Wiczynski is not mentioned here, but I can give you the URL too. Mm-hmm.